Hello, welcome to Bedroom Builds at the From Python to Rust series, episode 28, XML, coming from the previous episode where we spoke about sockets. XML is a really vast topic with lots of details like schemas and validation and DTDs and different formats even and protocols that are based on XML. But for a short introduction for which parsers and modification tools are available in the two programming languages, this doesn't make sense. So I will only cover a minimal example that parses in two different libraries for both languages and modify some nodes and write out the XML again. The basic file was taken from a sample from the University of Geneva EduTech wiki that's on the Creative Commons license, so you might want to check them out. Let's hop over into the code. So on the left, we can see Python as usual, and on the right, we see the Rust code. In both cases, I use a library that's called the Minidom. So this is part of the Python standard library. And this Minidom, of course, is a crate that you will have to install and use in Rust. I will quickly show you also the XML file. So this is the XML file. We have the standard header, right? We have a CD list that needs to have a namespace. We will get into this on the right side in the Rust code because Minidom requires that. Without this notation, the parser will simply not work as of today. And you can see it's a simple structure. This whole thing has a title. We have CDs. Each CDs have an artist, title, genre, description, and whatnot. And the minimal one would be only CD, artist, and title. Let's go back in to our Python code. The Python code for Minidom, this is giving you a similar interface as you would have traversing the document object model in JavaScript on a HTML website. So you get to use methods like get elements by tag name, for example, or create element, create text node, and stuff like that to traverse and create things. In Python, in order to create a buffer to write to and not write to a file, we can use IO's string IO here at the bottom. So that's the second import that we use up the top. Parsing is really easy in Python. You just use Minidom. I shortened it to MD. So I go MD parse, file name, and it's parsed. Then you can loop over all the child nodes and simply print them out. This will create a debug output, but gives you a good idea of where you are at right now with your path that you've created up here. Then this is very powerful, and that does not exist yet in the Rust libraries. If you use get elements by tag name, it will actually get every title tag that it finds in the XML document. That's very convenient, and the same is true for a track. You don't have to even know where it is, the element track, in which parent elements it's nested. You simply use this powerful function and it'll give you an iterator over those elements. And the first one, we show the title, and this is how you will get the text value, the content of the tag if you want. And here with the get attribute, you will get the track number printed out. And below here, we start creating a new node. First, I create an alias so I don't have to write this all the time, called root for the root node that was created after parsing. Then I can use the DOM to create a new CD that has an artist. This artist has a text node because the artist's name is Bob. And this artist is from the country Germany. So we create an attribute. So once we've created this, we can append the artist to our new CD. Since our CD also needs a title, we create a new element title with a text node that is the title name. Append the child to our CD again. Now we can append our CD to our root. And here we create our writing buffer, a string IO, and rewrite the XML to the string IO. Once this is done, we print the value. The same code, more or less, since we don't have the convenience function, it doesn't work exactly the same way, is on the right in Rust. So we import our Minidom element for ease of use. Then here we define a const for our namespace. And if you remember from before in the XML, it was empty. The reason is Minidom requires to have a namespace definition in the XML file. If this is not the case, it will refuse to parse as of today. There is an issue filed already, so it might change. Now, the easiest to read from a file I've already shown in a previous episode. So you use the standard file system read to string to get the cdlist XML's data. And once we can call the parse on it into an element type, and we panic if the parsing fails. So what it provides very similarly is the first loop. So on the left we have the for child in child nodes. So this will actually do the same, but the next loop already is different, because here it will give you all the title nodes that it finds anywhere in the document, and this one also only will filter nodes that are titled with the namespace that are found in the children of root. So this will only show one title and not all titles, as this loop does. If you wanted to recreate this get elements by tag name function, you can, of course, and I assume the creator of the Minidom library will be happy to accept that as a pull request. But as of now, this doesn't exist, or I haven't found it in the documentation. Then below, we try to get the track number. So here you will see the difference in code. I have not used any recursive tricks. I will simply move my way down into the document. So we start with a CD. Inside the CD, we filter for a track list. So if we found a track list, we will go through all tracks. And here we get the attribute number to get our track number printed. So you see that this is more code, and you have to know about the structure of the document. This is not as convenient as we have in Minidom in Python as of today again. To create a new element, the Minidom library uses the builder pattern, and that's fairly easy to use. So we have the element builder, then we create a CD. We have to provide the namespace. It's empty. Then we append an element artist that gets, if we just append a string, it will create a text node for us. So Bob becomes the name of the artist, and we create an attribute country Germany, and Bob, the German, now gets appended his song's title. And again, we use append only with a string, and it becomes a text node automatically. We have to call build at the end, because this will then actually convert this from a builder into a node. Then we can use our roots append child to attach our new CD. And once we've done that, we don't have to import any IO tricks. We simply create a vector of U8s that is mutable. And with this mutable vector, we can use the write2 method, pass the mutable vector. We expect this to work out. That's why I can use unwrap. And in the end, to print this, so I will disappear. In order to print this, we have the print line here. We can use the string from UTF-8, because this will be valid UTF-8 of the buffer. And we also expect this to work out, because the XML writer will write valid UTF-8. And then we can print the new XML that we created with our CD attached. Well, let's quickly run the code. Here I can return to the screen. So first, on the left, we have the Python code, Python minidom.py. So at the beginning, we have our loop that shows us the child nodes. And then the titles it finds. It finds every title, as I said before. Then we have the 2 track numbers. And here it already starts printing out the XML that we created with our Let's check if that's true. With our CD that we created with Bob, the German, as the singer at the bottom. Let's compare the output of Rust to all of this. And we go cargo run Minidom. And if I disappear, you can see that we also get our song attached. The output, of course, changes, so the track numbers are simply 1s and 4s, and here we get a sum, and it's a string, because I haven't unwrapped and I haven't parsed this into numbers yet, but we actually navigated to the tracks and we got the correct values. Then we only get the first title, which is the title of the whole document and not of an individual CD. On the left, you can see that the get elements by tag name actually gives you all titles that were found. And at the top, the loop for giving the children shows you the output, so you can see everything that it was parsed into, like the new lines and the tabs would be a text node. Then we have a text node for as a child of a tag, and this way you can actually figure out how your structure looks with the debug output of the elements. Now let's hop over to the other example with XMLTree and ElementTree being used. So we can actually, on the right, scroll up. Okay, done. On the left, we are now using the ElementTree parser and system of Python. That's also part of the standard library. And here you can do some more elaborate parsing than in the other one. I shortened it to only use this as ET. Then we can use it as in the other one. We just use ET parse and the parsing is done for us. We can get the root node using that. Same thing as we did before. We have this loop where we get our child nodes. Here we get the titles and the tracks. If we want to create an element, we have a sub element. This will create our CD node under the root node. So here is already a helper function where you don't have to append it at the end somewhere. It already does it for you. So here we can then already make the sub element artist underneath the CD with our Bob, and the same is then true for the title. And we use the method dump of the root to get dump onto the standard out of our XML. On the right, we use the XMLTree crate. I import element and XML node. I kept the hello world line, interestingly. That's not part of the actual code. So we use a read to string again to get our XML into our data that we need. Then we can use parse again to make our root node. The loop for the children works the same. If we want to get a title, we can use the get child. So that would be similar to the iter, but then again, it's not the same because this will only get, again, the titles found in the root node. So we don't have this convenience function that exists in the Minidom of Python. Yeah, if you want to have the text node, you have to use the sText, or you can use it this way with get text. Then you will only have the text node and not the whole node in your output. And here we go to the example where we get an attribute. So we hop into the CD. Once we are in the CD, we hop into the track list. From the track list, we hop to the tracks. Once we have a track list child, we can use the track number with going through the attributes. And all we have to do, this is a hash map, basically. We can use it this way. The new elements are created this way. So you use the element new constructor with the tag name. So I create a CD, an artist. Then I can use the artist to push a new node that is of type text, that is Bob. And with toOwned, I convert Bob into the expected type for text. So here it's a string, but then this text node will own the string. So toOwned makes sense in this case. For attributes, similar trick, but as I said up here, this is a hash map, so we use the insert with the key country, the attribute, and the value being the German short ISO code. Then for the title, it's the same as we already had for the artist's name. We repeat our XML node pushing to the children of the title element. Once this is done, we can now push an element called title to our new CD. And once we've done that, we can go to roots, children, and push the new CD to our list of CDs. Once we have done that, again, the trick from before, we create this vec-u8 buffer, we write to it, and we print the from UTF-8 interpretation of it. Let's quickly check if this all really works. We jump back into Python. This is now the Python code. And we get to see it kind of works out. But again, the convenience is given. At the top, you can see we see all titles and not just one, the first one. We get our track numbers, and at the bottom, you can see we have the song for Alice. Now for the Rust code, we can clear this. We run cargo run XML. And here at the bottom, you can see that it disregards all formatting, this parser at the end. So once we dump it, we get just one long string that has all the things. But song for Alice, you can see at the bottom, is being added. So that code worked out. You can see that we only get the first track number since we don't have a loop, and we only get the title of the whole CD collection because this getChild is not as convenient as it is in the Python libraries. They will only give you really the first child they find in the parent node. Again, if you want to contribute to those libraries, they will for sure be very happy. What you can see here is that the convenience is given in Python for sure. Speed difference will actually be not too much, I think, because Python is actually using a C library in the backend to do all the XML magic. From my point of view, the XML ecosystem of Rust will for sure continue growing and improving. But unless I have the requirement of, I don't know, parsing a 10 GB size XML file, I think I will still stick to Python for now for this task. Thanks for watching. Coming up next on the From Python to Rust series will be JSON.